In this session, we'll be studying the synchronous machines. We'll be discussing the basic concepts of synchronous machines and its construction. So what's a synchronous machine? It's an AC rotating machine. We have already studied the induction machines. The second type of the most widely used AC rotating machine. Other than that, we have the synchronous machines. Now, synchronous machines, as synchronous generators, they have been widely adopted in power plants. They are also known as alternators, while as synchronous motors, not though as popular as induction motors, but they do find a great deal of use where precise and constant speed applications are required. So the synchronous machine is a doubly fed AC machine. We supply the DC voltage to the rotor to produce the field, and an AC voltage to the stator or to the armature. We can either receive the AC voltage from the armature, or we'll be supplying the AC voltage to the armature. Now we'll be discussing the construction of the synchronous machines. The basic construction of a synchronous machine looks something like this. The stator will be carrying the armature windings and the rotor will be carrying the field windings. It was opposite in case of induction machines. Now, rotor is more like an electromagnet, and based upon the types of rotor, we have a salient pole construction and a non-salient pole construction. A salient pole construction salient refers to protruding. That means in this case, the poles on the rotor will be sticking out of the rotor surface, while as in case of non-salient, the poles will be uniform with the surface, and therefore the rotor will be cylindrical. So this is the construction of a salient pole rotor. Notice the protruding holes, and this will be the look of a non-salient rotor with a cylindrical surface. Now there are two methods of supplying the field voltage to the rotor. One method will involve the slip ring arrangement and the brush that we have already discussed. As the rotor is rotating, we need to make some arrangement for the rotor windings to not twist. This will be used in smaller machines, while as in larger machine, brushless exciter is used. It's a small AC generator whose field circuit is mounted on the stator and the armature circuit is mounted on the rotor shaft. The AC voltage from the exciter is actually rectified to DC voltage using a rectifier, which is also mounted on the shaft, and this DC voltage will then be fed to the main DC field circuit. Using the rectifier arrangement, we can control the DC voltage output fed to this main field windings without the use of slip ring and brushes. So this is the configuration of the exciter circuit. We can see the stator and the rotor of the exciter circuit rectified using a three-phase rectifier feeding the synchronous machine. In another configuration, we use a pilot exciter along with the exciter circuit. Pilot exciter will be fed through a permanent magnet DC motor. So in this case, without using any external power source, we will be able to produce the DC field. So this is all about the constructional details of synchronous machines. As far as the stator of the synchronous machine is concerned, it is somewhat similar, having slots and teeth carrying the armature windings in this case. So in the next session, we'll start with the principle of operation of synchronous generators.